So when we do arc length for polar curves, we have to use the general formula. It's the integral from a to b of the square root of r squared plus dr d theta squared d theta. Okay? This is the formula we're typically going to use. So in this case, this one's pretty straightforward because r squared is equal to 4 and dr d theta is equal to 0. So this is going to be the integral of the square root of 4 d theta. And this is a circle with radius 2, so you can go from 0 to 2 pi here. And that's 0 to 2 pi 2 d theta, which is just 2 theta from 0 to 2 pi, which is just 4 pi, 2 times 2 pi. And that makes sense. That's the circumference of a circle, right? Because this is a circle with radius 2. That means at all angles, the radius is 2. And so the circumference is, 2 pi r, which is 4 pi in this case. So let's do 4 cosine theta. This is another circle. And we go from 0 to pi. See, this is where I always have to remember. I have to sketch it out. So I'm at 0, I'm at 4. And then it goes up. It hits 0 at pi over 2. So it's the top half. Oh, yeah. So I have to go 0 to 2 pi again. So let's do r squared. R squared is 16 cosine squared theta. Dr d theta is equal to negative 4 sine theta. And so when I squared this, dr d theta squared, I get 16 because the sign goes away. Or the negative sign goes away. And so when I do r squared plus dr d theta squared, it's going to be 16 cosine squared theta plus 16 sine squared theta. I can factor out a 16, and cosine squared plus sine squared is 1, so this is just 16. So then the square root of this is just 4. So then this becomes the integral 0 to 2 pi 4 d theta, which is just 8 pi. And that's the circumference of a circle with radius 2? No. 2, 4, yeah, 8 pi. Thanks for watching. If you enjoyed this video, I go through a lot more of these exact kinds of problems with much longer videos on my website. It's entirely free. Check out the link in the description below.